right, here's our next example. Now, remember we talked about that the title of the section is doing problems of quadratic type. So this one definitely has more characteristics of being a quadratic than the other one we did. We can definitely see that there. Can you see the pattern of it being a quadratic? Okay. So back the very beginning of the year in Math 1050, we learned a procedure for solving things that look quadratic but aren't really, called substitution. You guys remember that? So do you think we could use a substitution with this to make it a little bit easier? You don't have to use a substitution, because once you've kind of gotten the hang of these, you'll be able to do them without the substitution. But I want to like simplify it down a little bit so you're not getting stuck in the cosines. You can see better what's happening. So should we use u like they usually do for this type of thing? Do you care? Okay. U equal cosine of x over 2. How did I decide that that's what my substitution was going to be? The middle term, that's what that is, right? And then if I square that, I get the first term. Good. Okay. So now let's go ahead and plug that in. We get 6u squared minus 7u plus 2 equals 0. So now it's a simple quadratic, no trig involved right now, to go ahead and solve this quadratic. So what would we do? Factor. Good. This one's a little bit harder. 6u, I don't know, 6 times 2 is 12. And then factors of 12 that add up to 7. 3 and 4, so we actually don't want to use a 6. Should we do this that one way? Let's do this problem that one way. Okay. I know that's a bad way of describing the method I'm using, isn't it? That one way. What is it called? Oh, it has a name. Expansion and grouping. That's what we're going to do. Okay, so we take the first and the last terms and we multiply them together. So 6 times 2 is 12, right? And then we factor 12. So we have 12 and 1, or 6 and 2, or 3 and 4. And we need to find 2 factors that would add up to 7 in the middle. Okay. But yeah, we want a positive 12 here, but we need a negative there. So if we do 2 negatives, negative 3 plus negative 4 is negative 7. But negative 3 times negative 4 is positive 12. So that works. Okay, so then we expand it. We expand it by taking the 7 and rewriting it as negative 3u and negative 4u. I know we did these at one point. No, we're not even close to the answer yet. Oh, you've got the answer. Okay, good job. Okay, now we can factor by grouping. So we can group those two and group these two and then factor out the greatest common factor out of each group. So what's the greatest common factor out of our first group? 3 and also u, isn't it? So we get 2u minus 1. Right? Okay. And then in our second group, we can factor out what? Well, 2 factors out, but remember how we want this to match? So yeah, let's make it a negative 2. So now that these 2 factors match, it's like we're factoring that out, and then these are left together. So our final factoring is 2u minus 1 times 3u minus 2 equals 0. So then can we take each of these factors and solve them? Right? So let's go ahead and solve this one for u. So 2u minus 1 equals 0. So 2u equals 1, so u equals 1/2. this one, 3u equals 2. So u would equal 2/3. Now that we've solved for u, we want to do what with our substitution? Plug our substitution back in. So we will have cosine of x over 2 equals 1/2. And cosine of x over 2 equals 2/3. Does everybody recognize the 1/2? The 1/2 is one of the exact 30, 60, 90 ratios, right? So cosine equaling 1/2 means that that angle would have to be what? Okay, don't double it yet. Don't double it yet. Ignore the fact that, just leave that part together for now. So cosine of some angle equals 1/2. What's the angle? 60, but we're doing these in radians, so pi/3. And probably just in case we ought to do our 2k pi just in case, although I think it's less important with these and more important if it was like 2x, right? Okay, so that's quadrant 1. Is there another quadrant? So x over 2 would also equal a 4th quadrant angle, which would be what? 5 pi/3, possibly plus 2k pi, but probably not. Okay, now go ahead and solve the issue with the half. How do you solve a problem that has a half in it? We multiply everything by 2. Good. So multiply this entire thing by 2, and we get x equals 2 pi/3 plus 4k pi. Well, I think if we add any values of 4k pi to this, other than k being 0, that it's going to go too far past our interval, right? We're trying to just do from 0 to 2 pi. That would go, wouldn't it? No, it's just from 0 to 2 pi. Find all solutions from 0 to 2 pi. Sorry if the word all confused you. Find solutions from in this interval. But really all still works. It just means all the solutions in that interval. So, okay. So we don't need the 4k pi, right? It's just going to be 2 pi/3. Okay, now let's do this one. Multiply that whole thing by 2. X equals 10 pi/3 plus 4k pi. Well, what do you know about 10 pi/3? That's also past 2 pi. So what's the only answer that we get from this little piece right here? X equals 2 pi/3. That's the only one we can use because we're doing 0 to 2 pi. Right? Did I lose you? Are we okay? Good. Okay, now let's focus on this one. Is 2/3 on our chart? We have square root of 3 over 2. We have square root of 2 over 2. We don't have any 2/3 on the chart. So what happens if we get a number that's not on the chart? We don't do it! Daniel, that's what you do. No. Wrong answer. I'm just kidding. Should we go ahead and find approximate answers using a calculator maybe? How's that sound? Shall we? Okay, so that means that the inverse cosine of 2/3 equals x over 2. So let's put that in our calculators. Inverse cosine of 2/3, what do we get? Where did I put my calculator? Now, remember how we're trying to answer this question from 0 to 2 pi. So is it important to know what mode I'm in? Yes. This is in degrees. What mode do I actually want to be in because of the question? Okay, I need to be in radians. And then let's try it again. So 0.84106. So that means, I don't know how many decimal places I should go, whatever. That equals x over 2. So then how do we find x? X will be by taking this number and multiplying by 2. So 1.6821. Now, do I need to worry about a quadrant 4 answer for that one? Technically, I should worry about a quadrant 4 answer, but what happened the last time we tried doing a quadrant 4 answer? When we doubled it, what happened to it? It went too far past 2 pi. So think, are we really going to need to do the quadrant 4 answer? No, because it's going to be bigger than we need it to be. Okay, so we have 2 answers, 2 pi thirds and 1.6821. So this one's exact, this one's approximate because we had no other choice since this ratio is not an exact one. I guess we maybe had a choice. Could we draw a triangle to do that one? I don't know. We're not going to worry about that right now. Okay,